So question 15a asks us to solve a linear quadratic system, a line, and a quadratic system, quadratic equation, and find the points of intersection, if there are any. So the first step is we set y equal to y, that point of intersection, that will be true. So what do we end up getting? We solve for x. 4x squared minus 15x plus 20 equals 5x minus 4. And what do we do next? Well, we put everything on one side. 4x squared minus 15x plus 20 minus 5x and plus 4 equals to 0. Okay, so the next step is 4x squared, collect like terms. These are the same. Minus 20x. These are the same. Plus 24 equals 0. And now we just solve for our x. Now, there's lots of ways we can do it. The easiest way is to factor. So the first thing I want to do is divide both sides by 4. So divide this by 4, divide that by 4. Well, 0 divided by 4 is 0. And 4x squared divided by 4 is x squared. And 20 divided by 4 is 5. And then there's x that's left, and 24 divided by 4 is 6. So we're left with this equation. Now, is this factorable? The question we need to ask is, can we have some number that multiplies to 6 and adds to, and sums to negative 5? Well, what numbers multiply to 6? 6 and 1. Well, can we get two values, 6 and 1, that add to 6? Sorry, that multiply to 6 and add to minus 5? Well, 6 and 1, well, maybe 6 minus 1, or minus 6 plus 1. But this, again, doesn't multiply to positive 6, so that can't be the case. What about 2 and 3? Well, 2 and 3 multiply to 6. Minus 2 and minus 3 also multiply to 6, and they add up to minus 5. So I have a winner. So the answer is x minus 2, x minus 3 equals to 0. So in order for that to be true, that must be 0, or that must be 0. X equals 2, or x equals 3. Okay, so we're almost done in that we need the actual point of intersection. It intersects when x is equal to 2. So we just substitute it back into our original. Y equals, at x equal 2, y equals, right there, 5 times 2 minus 4. Y equals 10 minus 4. Y equals 6. So one point of intersection is 2, 6, and at x equals 3, y is going to equal to 5 times 3 minus 4, which is equal to 15 minus 4, which is equal to 11. So I have x is 3 and y equals 11. Another point of intersection is equal to 3, 11. And that's how you find the points of intersection between a line and a quadratic. Now, the next question asks about, okay, so let's see, minus 2, 9, and 9. So let's do that question. Just pick a different color. Minus 2, 9, and 9. And I'll just fix that in a second. I'm just getting the coefficients. And the other one is minus 3 and minus 5. Minus 3 and minus 5. So it just goes x squared, x, and this is x, y equals. There we go. So I have a line, and I have a quadratic equation. Now the question is, what's the points of intersection, if there are any? So the first step is to set y equal to y. So I have minus 2x squared plus 9x plus 9, and then I bring the, and that's equal to minus 3x minus 5. And the next step is to bring everything over to one side. So I'll rewrite everything again. Plus 9x plus 9. And I say plus 3x and plus 5 equaling 0. So what's the next thing we do? Well, we collect like terms. Minus 2x squared plus 12x, and 9 plus 5 is equal to plus 14 equals to 0. Now I want to divide by -2. I want to get rid of this 2 so I can divide both sides by -2 again. And let's see if I can factor. So I get x squared, and you know what I'm going to do? I'm just going to write the minuses first so I don't make that mistake, and divide that by 2. 6x minus 7 equals 0. Now the question that you can ask yourself is, give me two numbers that multiply to 7. Well, 7 and 1 multiply to 7. Can I get a -6 from that? Well, 7 minus 7 plus 1 equals to minus 7, and it adds to minus 6. So in fact, that's equal to x minus 7, x plus 1 equals 0. So it was factorable. So what does that mean? That means that x, in order for this to be 0, if this is, in order for this whole term to be equal to 0, this must equal 0, or x plus 1 is equal to 0. So what does that mean? That means x equals 7, or x equals minus 1. Now, because we want a point of intersection, what we have to do now is we have to substitute it in our equation. I'm just going to use this. I'm just going to use this equation here. I should have duplicated it, but it's okay. And I'm going to say at x equals 7, y equals minus 3 times 7. That doesn't make sense. Is it minus 5? Let's see. It was minus 5. Minus 3 and minus 5. Okay, minus 5. So y is equal to minus 21 minus 5. Y is equal to minus 26. And at x equal minus 1, y is equal to minus 3 times minus 1 minus 5. And what do we end up with? We end up with 3 minus 5. Y is equal to minus 2. So my points of intersection are 7 minus 26 and minus 1 minus 2. And that's how that question is